Hello everybody, welcome back. Today we are going to continue practicing with the Chatelier's principle. Yesterday was the kind of introduction to it, and today we're going to actually apply it to questions. Now, this is not something you really should memorize. If you're just thinking about it, all these different things can kind of pop into place. So the way we're going to structure it is we're going to focus on this one equation, and each box essentially is a question. So this is like 20 plus questions in one table, and once we get the hang of it, it actually is not bad at all. So yesterday we had talked about what this was and how it works, and it kind of sucks that we're not doing this together because I love this unit, and I normally show you guys the Waka Waka video by Shakira, and there's a dance that kind of helps picture this. But if you haven't watched that video, first, it's a great song. Second, there's like a hand movement, and that kind of helps explain this topic. So let's jump into practice. Okay, so our first question, we're going to add N2. So when you're looking at a Chatelier's question, you want to figure out what side is stronger. So if you add N2, and I would always put left and right on your paper. You're not dumb because you forget your lefts and your rights. I forget that all the time, so it's a very easy way to prevent dumb mistakes happening. So if you add N2, again, we're going to split it. Left side is before the arrow, right side is after the arrow. So if you add N2, what side is stronger? If you said the left, you were correct. And that means the left side is stronger, so it's going to take control and push it towards the right. So normally, the left side and the right side are equal straights. But if now the left side is stronger, it pushes everything towards the right. So now, if you're pushing towards the right, that means you're using the forward reaction. So any reactant, like H2, will go down because it's being used up. And then the product, the thing you're moving to, goes up. Now, backtracking a second, you can use A, T, T to kind of help you out. So what this stands for is add, away, take, towards. So if we're adding N2, you move away from it. So it kind of helps you with the directions. Okay. If we are going to, add H2, so number 2, the left side is still stronger, and you're still going towards the right. Now if you're going towards the right, that means the forward reaction is happening. So your N2, your reactants go down, and your products go up because you're moving towards making them. Next is NH3. So now if you add NH3, the right side is now stronger, so it goes to the left. So now if you're going towards the left, we're moving towards the N2, so we're going to make that, and we're also making H2. So it's important to remember these reactions can go both ways, and we're just looking at which way we're actually going. Okay, so now if we remove N2, we're removing this. So now, if we're thinking about what side is stronger, if you're removing from the left side, the right side is stronger. So we're moving towards that left side. So that's where the TT comes in the AATT thing. If you take something, you move towards it. So again, if we're moving towards the left, we're favoring the reverse reaction. So we end up making H2. We end up using NH3 to make it. If you remove H2, it's the same thing. You shift towards the left, and you're making your N2, and you are using up that NH3 to do so. If you remove, and change colors here, NH3, now the right side is the weaker side, so left is stronger, and you're moving towards the right. So when you do that, you're using NH2 and you're using H2. Okay, so that's all the shifts when it comes to adding and removing stuff. And then we can talk about temperature and pressure. So when we're talking about temperature, we're talking about energy. So here you'll notice that you have plus 91.8 kilojoules. So that is the heat energy that we're talking about. So if you add temperature, you're essentially adding heat energy. So you're adding to the side that the number is on. So if you're increasing temperature, that means you're making the right side stronger, so you're moving towards the left. And if you move towards the left, you're moving towards N2, and you're moving towards H2, you're making it. And you're using that NH3 to do that. If you decrease temperature, it's the exact opposite. Now you're moving towards the side you just took from, so you're taking from that number. So the forward reaction is favored. So your N2 and your H2 are being used up to make that, and then your NH3 goes up. Now, last one is pressure, and pressure only affects gases. So when you're looking at this, you want to figure out how many moles of gas you have on each side. So on the left side, we have 1 mole of N2, and we have 3 moles of H2. So that's 4 moles of gas on the left side. And the right side has 2 moles of gas. Now, if you increase pressure, you want to go to the side with the least number of moles. So, the side with the least number of moles is the right side. So that means we're going to move towards the right side. And again, if you're moving towards the right, you're using your N2 and H2, and you're making an H3. Now, if you decrease pressure, you move to the side with the most amount of moles, and that is towards the left. If you're going towards the left, you are making N2, you are making N2, and you're using that NH3 to do so. So, this just takes a lot of thinking, but it's not bad at all once you take the time to think. So, on the bottom is another chart. If I were you, I would pause this and then work on it, and then watch it to go over the end of it. So, welcome back if you paused it. Good job. Looking at this one, again, this is our left side, this is our right side. If you're adding H2, that means the left side is stronger and you're shifting towards the right. If you're shifting towards the right, that means the forward is being favored. So I2 is being used up and your HI is being made. If you add I2, you're still moving towards the right because the left side is now stronger. And now you're using your H2 and you're making your HI. If you add HI, now the right side is stronger, so you move towards the left. And when you're moving towards the left, you're making H2 and you're making I2, so both of those go up. Now, if we're going to remove stuff, if you're removing H2, the left side is now weaker, so the right side is stronger. So it's pushing towards the side you just took from. So if we're favoring this reverse reaction, you end up making I2, and you end up using that HI to make it. So I2 goes up and HI goes down. If we remove I2, we're still affecting the same side. So right side is stronger, so it moves left. If we're moving left, we are making H2, and we are using that HI to do so. If we remove HI, your right side now becomes weaker, the left side is stronger, so you always want to move towards what you just took from. So if we're going to the right, you are using up your H2, you're using up your I2. And again, that is all of the adding or removing, jumping into temperature and pressure now. Again, temperature is the energy. So if you're adding energy, you're adding to the side with the kilojoules number. So the left side becomes stronger and you're being shifted towards the right. If you are shifted towards the right, your I2 and your H2 are being used up and you are making that HI. If you oppositely decrease temperature, you're moving towards that number, whatever side it may be on. This side, you're moving towards the left. So when you're moving towards the left, you are making H2, you are making I2, and you're using that HI to do so. So that concentration goes down. Pressure only affects gases. And so if we look on the left side, you have 1 mole of H2, 1 mole of I2. So that's 2 moles of gas. And here we have 2 moles of HI gas. So which side has more moles of gas? The answer is they both have the same. So there is no effect in the specific case with pressure, because you have the same number of moles of gas on both sides. And that's it. So if this makes sense, great. If not, redo this worksheet. And then there is a capsule learning that will cover this material as well.